Hello and welcome to another session in physics. In this session, we will be looking at the topic electric charges, how it is produced, the production, the types, distribution of the charges, and its storage. But before that, let us review the previous lesson. Welcome back. At this point, let's talk about how charges are produced or production of charges. There's this experiment we used to do when we were little kids where we just get a plastic pen and we'll rub it vigorously on our hair or on our coat, and then we're going to try to hold it near a very small piece of paper. I'll ask you to do that experiment at your own spare time. Get a plastic pen, rub it vigorously on your hair or on your coat using this tip here, the tip of the pen, then rub it vigorously on your hair and your clothes. Get it very close to a tiny piece of paper, just very tiny piece of paper, and state your observation. Most certainly, if you did it very well, you would notice that the paper will be attracted by the pen. The reason for this is because charges have been created. Charges that led to forces of attraction were created between the pen and the paper. You know, some substances have been found to possess the ability to attract light objects once they are rubbed because of the charges that have been created in them. The light object as well as the rubbed material, when this happens, that is because they have been charged or they have been electrified with what we call static electricity. So just what do we mean by static electricity? Static electricity is going to lead us to what we call electrostatics. Electrostatics is a branch of the study of electricity. As you can see from the slide here, electrostatics has to do with the study of charges at rest. Of course, you know electro has to do with electrons. It is the movement or the flow of electrons that leads to the development or constitution of electricity. When these electrons are stagnant, that is what we call electrostatics. So basically, electrostatics is the study of charges that are at rest, charges that are static, charges that are not moving. It is a type of electricity that does not move. It does not move from one point to the other. Rather, it is always at that point in the substance in which it was produced. It is always static or stagnant. Now we have basically two types of charges. As you can see from the slide here, you see one is labeled plus, the other is labeled minus. And of course, that only goes to tell you that the two charges are positive charges and negative charges. Positive charges and negative charges. Now, the next slide is going to tell us how we obtain positive charges. As you can see here, a positive charge is obtained when a glass rod is rubbed with silk. Here you see a glass rod and then you see silk. Silk is like a very light material of cloth. That one we normally call lining or linen. When you get it and you rub it against a black rod, rub it for some time, you would notice that the two materials are going to get electrified and they're going to get attracted to each other because the glass rod is going to become positively charged and the silk is going to possess some negative charges. And of course, we know that according to the law of electrostatics, the fundamental law of electrostatics, it says that like charges repel each other. I'd like you to have this drummed into your head. Like charges repel each other, but unlike charges or the similar charges, they attract each other. Unlike charges attract. But that's just the way it is in everything in life. Opposites attract, similars repel. And that is the reason why your father did not get married to a fellow man like him, and your mother did not get married to a fellow woman like her, but your father had to meet your mother and they got married and they gave birth to you. So the same principle applies to charges here. Positive and negative will definitely get attracted to something and they would produce current. But if it is negative and negative, nothing will happen. If it is positive and positive, they will in fact chase each other away. We'll see something similar like this when we study or talk about magnets. Alright, so what about negative charges, how they are obtained? Look at the diagram here. You see an ebonite rod, and then you see an animal fur or animal skin. A negative charge is obtained when this ebonite rod is rubbed with fur. When an ebonite rod is rubbed with fur, or not just fur, when it's rubbed with polythene, negative charges are created in that ebonite rod, which leaves the animal fur positively charged. So always remember the fundamental law of electrostatics, that repulsion occurs when the two charges are similar to each other, and the opposite of repulsion, which is attraction, occurs when the charges are dissimilar, or that they are different from each other. So this is a diagrammatical representation of the fundamental law of electrostatics, which states that like charges repel and unlike charges attract. And that is basically the aim of this lesson, for you to get this law into your head. Like charges repel, they push each other away, but unlike charges, the similar charges like positive and negative, opposite, they will attract each other. You can look at the arrows and the directions that they are pointing towards. At this point, let's talk about conductors and insulators. Conductors are materials that allow electrons to pass through them easily. Any material that allows electrons to pass through them easily, they are said to be good conductors. Examples of these materials are metals, damp air, graphites, acids, salt solutions, the earth that we stand on, and the human body, like we've said, time without number. All these things are very good conductors of electricity. No wonder when you touch a naked wire or an unprotected wire, live wire that has electrons or electricity flowing through them, you're going to get electrocuted. Also, when it is raining, the atmosphere is damp, and because of that we see flashes of lightning. That is because ionization is going on. Charges are being created in the atmosphere, and we hear the resulting sound. When these charges are similar and they come close to each other, they repel each other in the form of an explosion, which we later hear as thunder. On the other hand, insulators are the opposite of conductors. Insulators are materials that do not allow electrons to flow through them. They do not allow electrons to pass through them easily. We have examples of things like plastic, polythene, bakelite, ebonite, paper, dry hair, silk, oils, glass, sulfur, and even wood. That is why when you see someone getting electrocuted, do not attempt to touch the person with your naked hands. The reason is because if you do that, two of you are going to get electrocuted at the same time, because the human body is a good conductor of electricity. But as a rule of thumb, it would be nice either to use a dry wood to try to rescue the person or push the person away from the point of contact. So the diagram here shows us some materials that are very good insulators and do not allow electricity to pass through them. At this point, let us talk about the distribution of charges. Take a very good look at this diagram and you see things marked X, 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 X. Now these X's, they are all charges. But that's not the point. The point is the spacing of the charges, how far apart they are from each other. Now notice at the base here, it seems like they are close. On top here, it seems like they are close as well. But watch here, at this path where it seems like there is a curve, a parabolic curve, you notice that the distance actually increases. The X increases in distance from each other. Now look at this point where it is tipped, where it is pointed. You notice that the X are as if they are tight, they are very close to each other. And that is how distribution of charges are. Experimental works have shown, as you can see from the slide here, that charges are distributed where there is a sharp curve. Where there is a sharp curve, that is where charges are distributed. At that sharp curve is where we call the surface density. That is the place where the charge is concentrated. So in your exams, they could label something like this: A, B, C, D. And they will ask you, at which point on this conductor or on this material is the charge highest? Is it in A, Is it in point B, point C, or point D? Of course, the answer to that is point B. That is where the charges, that is the surface density, where the charges are densely concentrated. And now, let's talk about storage of charges. We have so many devices that are used for the storage and transferring of charges. One of them is the electrophorus, which is what you can see here in the diagram. It produces electric charges by a process we call electrostatic induction. That is the process of charging a body by bringing it close to a charged body, but there is no contact between the two bodies. Another device that we use for the storage of electric charges is the capacitor. Capacitors, by their symbols, they are written this way. Their primary function is to store charges. Do take time to go through these notes that will be attached to this video, and thank you for joining us in this lesson. To refresh your memory on what we've just discussed, please take the test that will soon appear on your screen.